Let's consider the problem number 2 from the sample test. Okay, so this is what we know. We have a pole attached somewhere on the ground, and this point we will define as an axis. So there is a string attached to the pole, and this distance from the axis to the tip of the pole is 2.5 meters as shown over here. So let me remove it here. As shown over here, the distance to where the force is applied by the net is 1.8 meters, and this angle is known. Just anticipating that we'll have to find this angle, it will be 36 degrees. Okay, what I need to find the tension. I need to find the tension in this rope, in this cable. Okay, so everything is in the static equilibrium. I can write down the equations for the static equilibrium around this axis A. The forces which act on the pole, except for those which are applied at that point, there are also forces which are applied over here, and they create a non-zero torque. So let's consider first the torque due to the force exerted on the pole by the net, and it is 120 newtons. It is applied 1.8 meters away from the axis over here, and the angle between this force and the pole is 90 degrees, and sine of 90 is 1. So this is why I can write the associated torque. It will contribute with the positive sign, because this force tends to rotate the system counterclockwise. So it will be plus, the distance is 1.8 meters times 120 newtons times sine of 90, which is 1, so I will not even write it, plus. So now there is a torque created by the string tension force. So it is 2.5 meters away from the axis, times the magnitude of this force T, times the sine of the angle between the pole and the direction of the force, so times sine of 36 degrees. And in this sum, as we discussed here, it is 0. So now I can solve everything for T. Oh, by the way, so we have to also take into account the sign. The sign of this torque is negative because it tends to rotate everything clockwise. So it contributes with a negative sign. So now we can solve for T, and we will obtain 1.8 meters times 120 newtons divided by 2.5 meters times sine of 36 degrees. Using my calculator, I obtained 147 newtons.